Hi guys, in this video I'm gonna help you to answer a question in A-level math. The paper is paper 4 region 2, time zone 2 in May and June of this year 2022. This is question number 6. A car of mass 900 kg is moving up a hill inclined at the sign -1, meaning the inverse sign of 0.12 to the horizontal. The initial speed of the car is 11 meters per second. After 12 seconds, the car has traveled 150 meters up the hill and has the speed of 16 meters per second. The engine of the car is working at a constant rate of 24 kilowatts. And question A asks us to find the work done against the resistive force during the time 12 seconds. To summarize the question, we know the car is moving up an incline, a hill, and the angle of the hill is given by this equation, inverse sine of 0.02. That value 0.002 measure in radian, not degrees, okay? And using the calculator, you can calculate that value of the angle, the inverse of 0.12 radian. And the result will be approximately equal to 6.89 degrees, or it will give a result which is extremely close to the value of 0.12, because when an angle given in radian is smaller than 10 degrees. So you see, when we type the arc sign, the inverse sign of 0.12 radian, the value of the angle is also approximately very close to 0.12 radian. So we can take the value here as the sine of that angle also. So the angle is 0.12 radian, okay? And sine of that value, sine of the angle 0.12 here, sine of 0.12 radian will be almost exactly the same value, I can change this a little bit like it. So it is extremely close to the value of the angle given in radian. Assume that the car moves from A to B, from the top to the bottom, bottom to the top of the hill. The velocity at A is 11 meters per second. The velocity at B is 16 meters per second. And the time of the journey is 12 seconds. The question asks us to find the work done against the resistive forces. So firstly, we need to really understand what does it mean by the resistive forces here. In this car, there are 4 forces acting on it. Firstly, the driving force of the engine, the force F of the engine, making the car moving with the acceleration. We can calculate the exertion, but it's not necessary for this method dealing with energy. Okay. The second force is the weight acting on the car in the vertical direction and downward. We can resolve this weight into 2 components: W1, which is a part of the resistive force, down the incline in the opposite direction to the force F, and the other component W2, which is perpendicular to W1 in this direction, perpendicular to the incline, and that W2 is cancelled out by the normal force of the incline, which is here, the normal force. So we don't care about the normal force and W2, okay? The sum of W1 and the resistive force of the air and friction with the ground. The sum of these 2 forces is the resistive force, okay? It is the sum of the friction and the component of the weight, which is along and down the incline, the hill, okay? And W1 here is calculated by mg, which is the weight, times sine of the angle of the incline, which is 0.12 radian. Okay, or we can take the value of the sine of the angle to be almost 0.12 also. Okay, so this is W1. To find that work, we apply the conservation of mechanical energy represented by the first equation here. 1/2 mvv squared is the kinetic energy of the car at the top of the hill. Okay, mgh is the gravitational potential energy of the car at the top of the hill, with h is chosen to be the height of the hill, and that height of the hill h here is calculated by multiplying the distance that the car travel, which is 150 meter, and times sine of this angle, 6.89 degrees, which is also approximately equal to 0.12. So that means 150 times 0.12, the height. And in this equation of the mechanical energy, we choose the ground level, the bottom of the hill, the position A, to be 0 gravitational potential energy. Okay, the sum here, 1/2 mvv squared and mgh is the mechanical energy of the car at the top of the hill. Okay, and the mechanical energy of the car at the bottom of the hill is 1/2 mva squared. So the difference between these two mechanical energy at the two positions, here at A and here at B, which is this subtraction, is equal to the work done by the net force. This product on the right side, F net times the distance that the car traveled, this distance is 150 meter. Okay, this product is the work done by the net force, and the net force is determined by this whole thing here. The net force is the driving force F of the engine. Okay, the driving force of the engine subtract the resistive force, which I already explained down here. The resistive force is the sum of W1, which is mg times 0.12, and the Fr, the friction with the ground, and the air drag. Okay, so this difference in the bracket, the square bracket, is the net force. And when multiplying the net force with the distance d on both sides of this equation, this left side is work done by the net force, and it is expressed in detail by the equation on the right side. The question is to find the work done by the resistive force, which is this thing, and the resistive force, as I already explained, is the sum here. The component W1, which is mg times 0.12, and friction and the air drag. This whole thing again is the resistive force. Okay, work done against resistive force, meaning it will be exactly equal to the work done by that resistive force, which is this product. Okay, this is the work done by the resistive force. So that thing is equal to F times D here. F times D here is the work done by the engine. Okay, the work done by the engine is calculated by the product by multiplying the power of the engine, which is given in the statement of the problem, 24 kilowatt, which is 24 times 10 to 3 watts. Okay, multiplying that power with the time, which is 12 seconds, we get the work done by the force of the engine. Okay, which is F times small d here, and then subtracting that force of the engine by the work done by the net force here, which is equal to the whole thing here, So that is the method. Okay, and the final step is putting the values into this equation. The power is 24 times 10 to 3 kilowatts converted into watt. Okay, multiplied with the time 12 seconds. 1/2, the mass is 900 kilograms, velocity at B is 16 meters per second, and velocity at A is 12. The mass is, again, the physical potential energy. The mass is 900 kilograms, the G is 9.8 meters per second square, and the height of the hill is already calculated in the beginning of the problem here. Okay, that is 150 times 0.12. So using the calculator, you get the result of the work done against the resistive force, which is equal to the work done by the resistive force. 65,250 joules. Okay, so that is kind of complicated problem, huh? It's not easy at all. So the point is that understanding what it means by resistive force and what against. Now moving on to the part B of the question. The car travels along a straight horizontal road. There is a resistance to the motion of the car of 1,520 plus 4V newtons. When the speed of the car is V meter per second, the car travels at a constant speed with the engine working at a constant rate of 32 kilowatts. Find the speed. So, as we know, the air resistance depends on the speed. The faster an object moves in the air, the greater the resistance of the air. And this equation, 1,520 plus 4V, is the expression for the resistive force. Okay. Again, here's some summary of the problem. Now the car moves with a constant velocity, so the acceleration of the car is definitely zero, and that is the result of the net force to be zero, which means that the force driving the car upward, the force of the engine, the driving force, must be equal to the sum of all resistive force, including the component of the weight down the hill and air drag. And this resistive force is given by the expression in the statement, which is 1520 plus 4V. Okay. To find the speed, we will start with the equation of power, because the power is given here, and the question is the speed. And if you recall some equation in physics, there's an equation relating between power and speed, and that equation is here. The power equal the driving force times the speed. Note that this power, 32 kilowatts, is the power of the engine, not the power of the net force. The net force is zero. Okay, this is the power of the engine, and so that power is calculated by the work done by the engine divided by the time. The work is determined by the constant force of the engine. This force is constant, therefore we can use the equation, the force times the distance that the object moves, to calculate the work. So the work is Fd times the distance s, and the ratio between s and t is the speed, the constant speed of the car. Okay, so the relationship between power and the force of the engine is this: P equal Fd times V. And as mentioned, the driving force equal the resistive force. Therefore, this driving force equal 1520 plus 4V. Okay, and plugging back into the first equation here, the power is 32 kilowatts. The driving force equal the resistive force 1520 plus 4V, and then multiplying with V here, we have this following equation. Okay, and then we expand the expression. So 4V times V square, 1520V, and then move this number to the right of the equation. We have the quadratic equation like this, and we can use a calculator to find the solution of the quadratic equation. Now I will hit solving the equation here. It is a polynomial equation F2, and the degree is 2, meaning quadratic equation. The value A is 4, the value B is 1520, and the value C is minus 32,000, huh? Okay, so solve it. Here you see the first solution is 20, which makes sense. The speed of the car is 20 meters per second. The second solution is negative 400, which does not make sense because the velocity cannot be negative value. Of course, we've learned that velocity can be negative, indicating that it moves with in the opposite direction with the chosen positive direction. But for this problem, finding the speed, doesn't make sense for this value. So the answer for this question is the speed of the car is 20 meters per second. Okay, Thank you for watching, and I hope to see you in the next video. And feel free to contact me by leaving a comment in the comment part of the video or inbox me on the Facebook page. Thank you.